Okay, so let's start with some simple problems. Okay, so I am starting here with the concept of resistors. Here I have got three various combinations of resistors. They are in series combination also and in parallel combination also. So you can see here I have got three problems. Okay, so what is the question we have here is find the effective resistance between A and B. So here in all the designs I have the points A and B, A and B, A and B. So here between these 2 points A and B, what is the amount of effective resistance? That may be RS or that may be RP, we have to find. It depends on the combination. Okay, so see here. See here in the first diagram what we have between the points A and B, we have three resistors here, three resistors. Okay, they are connected end to end. This resistor's end is connected to this resistor's end. This resistor's end is connected to this resistor's end. But this is not same with this resistance, because between the 2 points A and B we have three resistors in series here. But this is not in series, this is in parallel with these combination. Means between the points A and B we have these three resistors which are in series, but this is not same. This is between 2 points. This is between 2 points A and B. It's like the whole combination is in parallel with this resistor. Understood? So here how can we find the resistor, effective resistor in this diagram? See here. The these three resistors, let's consider them R1, R2 and R3, and this is R4. R1, R2 and R3 are in series with each other. Hence we can find RS there. RS is nothing but what? Series combination of the resistor. So that is R1 plus R2 plus R3. So what we have? R1 plus R2 plus R3, 4 plus 4 plus 4. We have 12 ohm. So this we can draw like, see here between A, we have here now 12 ohm. By combining all these which are in series, we can get 12 ohm, and we have A and B here, and the resistor 4 ohm. Understood? I am just simplifying the diagram. These three resistors I can write as a 12 ohm because they are in the series combination, and this is 4 ohm. And now this 4 ohm and 12 ohm are in parallel combination with each other. So how can we write for parallel RP? That we have 1 by RP is equal to 1 by R1 plus 1 by R2. That we can write, how we can write it? We can write it as R1 plus R2 divided by R1 into R2. That is 1 by RP. But instead of that, what we can write for RP? R1 R2 divided by R1 plus R2. Means the formulas also we can simplify them according to the terms. Okay, so what we can write here? See, RP is equal to R1 into R2, R1 into R2, 12 into 4, and divided by R1 plus R2, 12 plus 4. 12 into 4 is 48, 12 plus 4 is 16, so it is 3 ohm. Answer we got here is 3 ohm. Understood? So this is how we have to find the answers for combination of the resistors. Okay, for your more understanding, let's consider another example. See here. Here also we have the points A and B. Okay, but here there is difference with these two diagrams. The diagram looks the same, but there is difference between the points A and B. Here we have A and B like this, and here we have A and B like this. So now how can we find? See here. For the second question, how can we find it? See here. Here between A and B, 3 and 6 are series with each other like this. And here between A and B, 2 and 4 are series with each other. So these 2 we can add, because RS is equal to R1 plus R2, and this also we can add. So how we can write the diagram there? See, between the points A we had 3 and 6. 3 and 6, add them, it is 9 ohm. Okay, and here we have point B, and here we have 2 and 4, add them again, 2 and 4 is 6. So now the combination of these two and the combination of these two, they are in parallel with each other. Now 9 ohm and 6 ohm. So how can we write for the parallel combination? Rp is equal to R1 R2 divided by R1 plus R2. What we have, the R1, 9 into 6 divided by 9 plus 6. So that is, okay, and divided by 54 divided by 9 plus 6 is 15, and 54 divided by 15 is around 54 divided by 15 is around 3.6 ohm we got. Understood? Okay, now look at the third problem. So see here, one more design we have got. We can say it is at a design, different designs we are having. Okay, so here see, between the points A and B we have some complex connections over here. So how means, first simplify this part. Okay, first simplify this part. So how we can simplify it? See here we have 2 points. Here we have 2 points. Between these 2 points, 1 ohm, 1 ohm and 1 ohm are in series with each other. Yes or no? And the combination is again parallel with this 1 ohm again. All the resistors are having the resistance 1 ohm only in this diagram. So see here, this 1 ohm and 1 ohm are in series with each other, and the whole combination is in parallel with each other. So how parallel with this 1 ohm. So how can we write the diagram? See here, third one. How can we write it? Means, but from A we already have 1 ohm, and this above combination now becomes 3 ohm, because they are in series. 1 plus 1 plus 1, 3 ohm we got. So that 3 ohm is in parallel with 1 ohm, and one more resistors we have, and here the point B. Okay, now this 3 and 1 are in parallel with each other. So how what we can do for parallel combination? R1 into R2 divided by R1 plus R2 we have here. So R1 into R2, 3 divided by 3 plus 1, 4. 3 by 4 ohm we got. Now can we write it again as 1 ohm? So these two parallel combination, these two resistors can be replaced by a single resistance, that is 3 by 4 ohm. Yes or no? You know the concept of effective resistor. Now again 1 ohm. Now see, isn't it? See this diagram and see this diagram. We are just simplifying the diagrams to get the values of the resistance. Okay, now this 1 ohm, 3 by 4 ohm plus 1 ohm, they are all in series with each other. So RS is equal to 1 plus 3 by 4 plus 1. So it is around 11 divided by 4 ohm. So the effective resistance of this combination is 11 divided by 4 ohm. Okay, so students, you can form your own designs. Means, isn't it a bit of, enjoyable for to do? Means, it's just like a game. You can enjoy while solving the problems like this. Okay, so you can make your own designs and you can find the effective resistance, so that your skills also will get developed, and with that you will get enjoy also. Okay, so such more you can create such more designs of this type, and you can again be perfect in the concept of combination of resistors. Okay, only thing is, while it is in series it is addition, while it is in parallel it is r1 r2 divided by r1 plus r2, or it is more than 3 means you can write it as 1 by r1 plus 1 by r2 plus 1 by r3. Again, this also you can combine and form a formula like this, but the simple way is 1 by rp is equal to 1 by r1 plus 1 by r2 plus 1 by r3, and so on. How many resistors you have, that many you can do. Okay, now so this is about the simple concept of combination of resistors and combination of resistors in series way and in parallel way. One more type one more type of the such problems is see here. We have studied the Kirchhoffs laws. So in Kirchhoffs laws we have two, KCL and KVL, Kirchhoffs current law for the, or you can also say it as a junction law, and Kirchhoffs voltage law. You can also tell it as a Kirchhoffs loop law. Now let's solve some problems on Kirchhoffs current law. What is the before going to that, you just remember what is the statement of Kirchhoffs current law. It says the algebraic sum of currents meeting at a node is 0. That is what? Sigma I is equal to 0. Or you can say number of currents entering the point O or entering a node is equal to number of currents leaving the point O or leaving the node, you can say. Depending on that factor, now we have a question like find value of I. So here in this diagram also we have I. In this diagram also we have I. Now we have to find the value of this I by using Kirchhoffs current law, the application of KCL. Okay, now see here in this problem. So here totally we have 3 nodes. We have 3 nodes, that is A, B, C. Okay, so now what is the phenomena happening at first node? You see, at the node A. At the node A, what's happening here? The current 5A is entering the node. So that is positive. Yes or no? Plus 5. Okay. And this current 1 ampere is leaving the node. Hence it is minus 1. And here the amount of current X is also leaving. So minus X is equal to 0. So that is what? The algebraic sum of currents entering and currents leaving at this node is equal to 0 according to KCL. Now, so what is the value of X we can get here? 4. So here we got X is equal to 4 ampere. Okay, now next at the node B, what's happening? The current 4 ampere is entering, so it is plus 4. Current 1 ampere is leaving, it is minus 1, and the current Y is leaving, minus Y equal to 0. Okay, so now what is the value of 4 minus 1? 3. 3 minus Y equal to 0, or Y equal to, you can see, 3. Yes or no? So this is why the value of Y we got as 3 ampere. Similarly, apply at the node C. At node C, what's happening? The Y, the 3 ampere is entering. 3 minus 2 is leaving, minus I is also leaving. Okay, so now 1 minus I equal to 0 and I is equal to 1 ampere. So here the value of current I is 1 ampere in this given circuital diagram. Understood? This is the application of KCL. This is not, I am enjoying while solving such problems. I don't know what about you. Okay. Now the second question also. See here also we have again 3 nodes A, B. No, only we have 2 nodes here. So here at node A, what's happening at node A? See here 3 is leaving, hence it is what? You also try to solve it. Hence it is at A, what we can write? Minus 3. And it is entering plus 7. it is x is leaving, so it is minus x equal to 0. 7 minus 3 4, minus x equal to 0, and x is equal to 4 ampere we got. Now this x is 4 ampere again. Okay, and here at the point B, what's happening? See here at the point B, what's happening here? 4 ampere is already entering. One more current I is been adding with that 4 ampere. Hence totally here the entering current is what? 5 ampere. Yes or no? Now this Y is leaving. Y is leaving and 3 is also leaving. See here, first 5 is entering and 3 is leaving. So 5 minus 3. 5 minus 3 is what? 2. 2, and this y is also leaving. Y is equal to 0. Okay, so what we have? Y is equal to 2 here. Y we got is 2. Now at this node, y2 is also entering and one more 2 is also entering, and that is continuing further as I. So what is value of I? 2 plus 2. So I is what? 4 ampere. Understood? So this is what, how to find the value of current by using KCL. Okay, so you can also form your own problems and you can develop your skills. Okay, this is about KCL. I have given only two simple things. I'll try to give the homework also. Some more types of these problems I will give as a homework. You can solve it. Okay, now we have studied about KCL. Now think about KVL, that is Kirchhoffs Voltage Law. Kirchhoffs Voltage Law. What is the definition statement of Kirchhoffs Voltage Law? We have already studied it. It is so many times asked in the exams also. You should not forget the laws. Ohm's law, Kirchhoff's law, anything it may be. Okay. So KVL states that the algebraic sum of EMFs and the IR products in a current loop is equal to 0. How we written that? Sigma IR plus sigma V is equal to 0. We have written it. Okay. So similarly, now while explaining the Kirchhoff's law only, I have given a simple diagram over there. Okay. So by using that, how we can write, how we can deal the problems. See. So here we have one circuital diagram which is a closed loop. What is the question we have? Apply KVL and find the values for I1, I2 and I3 in a given current loop. We have here one current loop. Yes or no? And you already know that Kirchhoff's law, Kirchhoff's second law works only for a closed loop in an electrical circuit. Closed path in a electrical circuit is nothing but a electrical loop. Understood? So in this current loop, we have to find the values of I1, I2 and I3. Okay, so how we can find it? See here. See here. So we have the points here A, B, C, D and one more F. Okay, now first consider the loop A, B, C, D, A. For the loop A, B, C, D, A. For the loop A, B, C, D, A, now apply KVL, Kirchhoff's voltage law. What happens here? So Kirchhoff's voltage law is the sum of EMFs, that is equal to sum of IR products, or you can say the algebraic sum is equal to 0 also. Now you consider first EMFs. EMFs we have two cells here with the EMF 3 volt and 4 volt. Now start in traverse in this direction, means moving in this direction in a anti-clockwise direction. So see here, negative to positive. The cell is from negative to positive. So if it is from negative to positive, we have to take it as a positive, plus 3. Okay, and now here, like come here again, this is from positive to negative. So when it is positive to negative, we have to take it as minus. Okay, so this is about the part sigma E. Sigma E is completed. Now the IR products we can see. The IR products we have to discuss. Now start moving in this loop in this direction only, anti-clockwise direction. Now here we have I1. With respect to that, R is 1 ohm. So we can write here I1. Okay, again come here. We come here. Again we have one more current I2 with the resistance 2 ohm, but we are moving like this and this I2 is in opposite direction. So we can consider this as 2 I2. Understood na? I hope this we have understood. You have understood. So call it as a equation number 1. Okay, now again we have one more loop over there. What is that one more loop? A, B, C, this one more, F, A. A, B, C, F, A. So here I am considering A, B, C, F, A. Because we have to involve this part also, as we have a closed loop here. Okay, now see here in this loop what happens. Here in this loop we have only, leave this part now, leave this part, only think about A, B, C, F, A. Okay, we have only one EMF, one cell of EMF 3 volt. Here we don't have any cells, that's why we have only 3 in the part of sigma E. Next, now again start moving in the clockwise anti-clockwise direction, traverse in this direction. So it is I1 1, that is I1. Again start moving. Here we have one more I3. We have current I3 and with respect to that the resistance 10 ohm. So we can write I3 10 ohm and the traverse direction is positive only. Okay, now we already don't know the value of I1 also, value of I2 also. But if you look at this network, see these two cells are in parallel with each other. I1 and I2 are in parallel with each other and I3 is the main current. So in such network, the main current we can write it as I1 plus I2 because this is a parallel combination of the cells. You can look at the explanation of parallel combination of the cells. There we have got the main current is sum of the branch currents. That's why here in the place of I3 we can write I1 plus I2 into 10. Again what we can get here, 10 I1 plus 10 I2, 3 is equal to 11 I1 plus 10 I2. Now call this as equation number 2. Now to get the values of I1, I2 and I3, we have to consider these two equation 1 and equation 2. So what we can do there, to the equation 1 multiply with 11. Because we have to cancel any one term. This is a method in mathematics, you know it already. Okay, so that is what, minus 1 is there, minus 11 equal to 11 I1 minus 22 I2. Equation 2 as it is, 11 I1 plus 10 I2. Now substitute this equation 2 from equation 1. So what happens here, minus 14, this plus 11 minus 11 get cancels, minus 22 minus 10 minus 32 I2. So what we can get I2 as 14 divided by 32, that is I2 14 divided by 32 means it is around 0.43. 0.43 ampere. So among I1, I2 and I3 we got only one now, that is I2 is equal to 0.43 ampere. Okay, now you see, do we have any one equation in such a way that we can find I1 by using I2? See here, minus 1 I1 minus 2 I2. This equation also we have and this equation also we have. We can use any one and you can find the value of I1. So here you use first one, minus 1, I1 minus 2 into I2. I2 is 2 into 4.3, 2 into 0.43, that is around 0.86. Minus 1 is equal to I1 minus 0.86. Now I1 is equal to, so it is minus 11 plus 0.86. So minus 1 plus 0.86, it is about I1 is equal to minus 11.14 ampere. Understood? So this is the value of I1. This is value of I1 we got. And now already you know I3 is nothing but I1 plus I2. So what is I1 we got? I1 we got minus 0.14. Okay, so I3 is equal to I1 plus I2. Minus 0.4 plus I2 is 0.43, minus 0.14 plus 0.43, so I3 is 0.29 ampere. So we got I1, I2 and I3. So this is how we have to solve the problems like this. Here where we have the Kirchhoffs network, we have to solve the problems in this manner. Understood? So you can solve some more problems of this type if you have textbooks, or if you can search it in net also, and or I also will give some examples of this type. Okay, so the moral is just what you have to learn how to apply KCL and KVL to the networks, to the different types of network. How to apply these two laws you have to understand. That is only the purpose of solving the problems. Okay, now this is all about the combination of resistors and the KCL and KVL. Okay, now start solving some difficult problems from the theoretical part. Okay, from theoretical part also I have got some problems. So see here, what is the question we have? I hope you can see it. See, what is that? Two resistances 4 ohm, 6 ohm are connected in parallel. The combination is in series with the another resistance of 2 ohm and a cell of EMF 2 volt and the internal resistance 0.6 ohm is connected. Now calculate the current through the three resistors and potential difference across the parallel combination. Okay, now I have one way of solving the problems which I will suggest you to follow. That whenever you got the problems, you have to follow 5 rules. 5 rules we have to follow. First one is, what is given in that problem we have to write. Solutions. Solution in 5 points. What is given in that problem you have to write. Next is, what is to find you have to write. Next is the formula which you are going to use in solving that problem you have to write. Next, the calculation, and the at last result. As you are PU students, you have to follow this concept. If you follow this concept, in the examiner will feel like you have one disciplined way of solving the problems. Okay, I suggest you to follow the same procedure while solving the problems. Okay, now with respect to the given problem, see what all the things they have given. Two resistances 4 ohm and 6 ohm. Okay, before going to that, you just analyze this situation. What's happening here? You just analyze what they have given. Two resistances 4 ohm and 6 ohm are connected in parallel. Okay, now let's connect them. 4 ohm and 6 ohm. 4 ohm and 6 ohm are connected in parallel. Okay, now the combination, this combination is in series with another resistance, means the combination is in series with another resistance of resistor 2 ohm. 2 ohm. Now here to this combination a cell of EMF 2 volt is 2 volt is connected with the internal resistance 0.6 ohm. So this completes what the diagram. The current I is flowing in this circuit you consider. Okay, and here the main current is I, but here I1 and I2. This is how you have to analyze the problem which they have given. If you make like this, it is more simple to solve. Okay, now what all the things they have given? They have given R1, that is 4 ohm. They have given R2, that is 6 ohm, and also you consider this as R3, or you can leave it, or you just consider it as R3 2 ohm, because these two we are combining after that. Okay, now okay, that all things they have given, and also they have given the EMF of the cell. They have given 2 volt, not only 2, it is 2 volt, and internal resistance are 0.6 ohm they have given. Okay, so neatly you have to write all the things they have given in the problem, that we have to write. Okay, now what they have told you to find, what the things you are finding in this problem, see here. They have told calculate the current through the 3 resistors. Okay, so the current you have to find. And the potential difference across the parallel combination. In this combination, what is the potential difference V is there na, that we have to find. Okay, now to find these things, what is the formula you are going to use? Now when you are dealing with the EMFs and cells and internal resistance, the value of I is the simple value of I is what? V divided by R. But in the case of cells, instead of potential difference, what will be having? EMF, and the R is a combination of external resistor and internal resistor. So this formula we have already obtained in the theoretical part of cells. So this formula we are using to find I. And to find V, which formula we are using? That is simple, I R P. Because they have told you to find the voltage or the potential difference in the parallel combination, that is RP. Okay, now to solve this, for I also you will be considering R here, and here also your RP. So you have the formulas for RS and RP also, because we have here parallel combination also and series combination also. And so the formulas for RS is R1 plus R2 plus R3 also, R3, or for RP it is, see here, for RP here also we'll get R1 R2 only, because these two are combining and making one na? That's why R1 plus R2, and RP is what? R1 into R2 divided by R1 plus R2. So these all formulas we are going to use in solving this problem. Okay, now let substitute these values in the given formulas to find the answers. Okay, now for this I, we have to find RS and RP first. Now in these two resistors, now find RP. What is RP here? R1 R2 divided by R1 plus R2. That R1 into R2 means 6 into 4. R1 plus R2 means 10. So it is 2.4 ohm. So how this becomes now? 2.4 ohm and 2 ohm. Like this it became now. This combination I am replacing by 2.4 ohm. Now what is RS? We can write 2.4 plus 2. So it is 4 plus 4 ohm. So the whole combination resistance becomes what? 4.4 ohm. Yes or no? Because these two combination, the effective resistor of these two resistors is 2.4, and the same is continuing with 2 means the whole combinations resistor, effective resistor, becomes 4.4 ohm, and that is nothing but RS. So here they have told to find the current through the 3 resistors, means the current through whole combination we have to find. That's why we are using this RS 4.4, which is the effective resistance of all the 3 resistors. Hence I is equal to E divided by RS plus R. What is the value of E? We have 2 volt we have, and RS we have is 4.4, and the small r is 0.6. okay, now 4.4 plus 0.6 is 5. 2 divided by 5. Or you can also simplify it further, that is 0.4a. So I we got is what? 0.4a. okay, now one thing we have calculated. Next we have to find V. So what is V? V is equal to IRP, because they have told to find the potential difference only across a parallel combination, not the whole combination. They have told only parallel combination. Hence we can use only this, means the resistor is what? RP, that is 2.4. Hence I we already got it as 0.4 into 2.4. So V is equal to 0.96 volt. The unit is also very important. 0.4 into 2.4. okay, now we got the 2. okay, and the problem is not finished yet. You have completed only 4 points. 5th point is also remaining still. Now here we result compulsory with unit we have to write. Understood? Now I is equal to 0.4 ampere and V is equal to 0.96 volt. This completes the problem completely. Understood? See here. This completes the problem completely. Okay? So these are the some problems we solved. okay, as I told you, I have collected the problems from the question papers also, from 5-year question papers. We can solve it in the next class. okay, you also try to solve the different types of problems from the different sources. You can use internet. In internet also you have so many applications over there, like Byju's app is there, Vedanta online education is also there. Means by that you can take some little bit extent of help. You can get various types of problems, various types of means whenever you feel bored, you can just have a glance at them. They are also helpful for you. Even though in the college we are helping you, but also already you have much time in the home now. That's why you can just have a glance at various things also. You will get a creative ideas about the concepts. That's why. Okay, thank you.